All right, welcome back. And in this tutorial, we're going to look at Math MAT 110, that is Cavendish University School of Medicine, and looking at your sheet 1. So in the previous class, we had looked at question 1 to 4. We now look at 5 to question 19 in this one, where we're going to be proving, illustrating, and on other parts where we find the power set. Then we move on to finding product set, and then we will talk of how to write these on a real number line. After writing it on a number line, we also then write it in interval form. So let's get into it. So the first question tells us to prove that, to prove that the difference of B and A is equal to B intersect A complement is equal to B intersect A complement. Okay, so now what are we going to do here? So in order to find this, we ought to understand what each part means, first of all. So the first part, B, the difference between B and A, just means all elements that are in the set B, so elements that are in B, but are not in what? In A. So elements that are in B, but are not in what? Are not in A. Then the other side, we're just finding the intersection of the set B and intersecting it with the set, that is the set A complement. Right, Mr. Jacob, volume. All right, so then we're intersecting this with the complement of what? The complement of A. So now how do we make about sense in this proof? So when you're looking at a statement, we did state that two sets will be equal. So B, the set difference of B and A is going to be equal to B intersect A complement if and only if B is a subset of B intersect what? Intersects A complement, and the reverse, that is B intersect A complement, being a subset of the set difference of B and what? And A, like that. So this is what we must show in order to prove the first question, which is question 5 there. So how are we going to do it? So we say, let's say we have an arbitrary element and we call it X. So I'll say let X be a member of B. So B is a difference of B and what? And A. So by definition, this implies that X is a member of B and X is not what? Is not a member of what? Of A. That is the definition of that set difference there. So now X is in B and X is not in what? Is not in A. But what does this mean? So this means, this implies that X is a member of B and X is a member of what? Of A complement. So if X is not in A, it means X has to be in what? In the set A complement. So, but then this just means that X is a member of what? Of B intersect A what? A complement. So this shows us the first one. So this shows us the first one. Then we say, so this means that, or this has shown us that actually B A is a subset of B intersect what? A complement by this. So we can even call it 1. Then I say, conversely, we can say, conversely, we let our X be, we start from the other side, a member of B intersect C complement. So if X is a member of B intersect C complement, what does this mean? This means that, or this implies that X is a member of B and X is a member of A what? A complement. But this also then means that X is a member of B and X is not in what? Is not, so X is a member of A complement, meaning X will not be in what? In the set A. So this implies this. But then this is just by definition the set difference between B and what? And A. So this then shows us, that B intersect A complement is actually a subset of B set difference with what? With A, like that. So we've shown the first part, we've shown that this is a subset of that part and the other way around. So we conclude uh, hence the proof. So hence the what? The proof. So this is the end of what? Of our proof. We've shown that actually B, the set difference of B and A is equal to B intersect A, what? A complement. All right. Next, our next question tells us to illustrate the De Morgan's laws. Illustrate the De Morgan's laws. And they're told we must use a Venn diagram to illustrate these De Morgan's laws. So first of all, you must know the De Morgan's laws before you illustrate them. So the De Morgan's laws, we have A union B complement. This is equal to A complement intersect B complement. Then the other one is A intersect B complement. This is just equal to A complement union B complement, just like that. So now, having this, so these are the two that we must show. So I'll first show part one, then we show part two. So now they're saying using a Venn diagram. So we just must verify or illustrate this, means we must show that this is equal to that. Yeah, using a Venn diagram. So how do I show that? So I say I write my set like this in my Venn diagram, then I write my two sets there. I indicate A and B there. So now, if so I'm saying A union B here. So A union B, then there's a complement, of course. So A union B, I'll shed first A union B. So the A union B is this here. That is my A union B. So this is my A union B. My complement, by definition, is everything that is not in A union B in this case, but sits in the universal set. So there our E or our U there is our universal set, meaning that it's going to be in that open space, this open white space that has remained there, meaning that is my complement. So to write A intersect, to write A union B complement, so A union B complement, so this is A, I'm saying this is just, A union B. Now I want A union B complement. So my A union B complement, I write my sets like this. There, then I have A, I have B here. Complement is going to be outside there, like that. So that is my my A union B complement, like that. Now I must show that this is actually equal to what? To the right-hand side where there is B. So the right-hand side is this side, which is A complement intersect B complement. So if I write my set here, so here, this is our A union B complement. So now I write my sets here, my Venn diagram and my two sets, A, B. So B complement, I'm going to shed A complement first. Everything that is not in A but is in the universal set. So meaning that there, I'm not shedding any part of A, but I'll shed everything else since it's in the universal set there. Like that, like that, like that, like that, like that, like that. Then the next one is just that is B complement. So I'll not shed B, but I'll shed everything else outside B. So there, like that, like that. I'm not touching B. There, like that. So then I say it's looking for the intersection. So the intersection, I just check where do these lines crisscross, and these lines crisscross on the outside there. So on that outside here, that's where they make that crossing. So in short, we just end up with that this here is just going to be, if I write my sets like that, the parts that had crossed there, so I have A, B, what had crossed is just the outside here, like that. Here, this is where they had what had crossed. And this here is my A complement intersect B complement, and just like that, I have illustrated on a Venn diagram. All right, let's demonstrate the other part of the De Morgan's laws. So the other part is A intersect B first. So you have A intersect B complement. So here I have my set, all right. Then I say here, there, like that, and another one like that. Then I have B, C, like that. I mean A and B. Then the complement. So A intersect B is here in between, that is A intersect B. But then we want the complement. So meaning everything outside this part is going to be my what? My complement. So everything there, like that. Everything there is going to be my complement. So I can write this nicely to say, okay, to say that my A intersect B complement. So 1, 2 there. So I write A, B, complement is just everything apart from that middle part there, everything outside there, I'm going to add to shade like this. So apart from that middle part there, everything else will be shaded. Okay, so just like this. So this is my A intersect B complement. Then I need to get the other part. So the other part, I write here first, and I say I have like that and that. So here we have A, so write A here and B. So A complement everything outside A. So everything outside A, I will shade like this. Everything outside A, not including the set what? The set A, but everything outside what? The set A, like that. Okay. Then I go to B complement everything outside B, not including what? Including B. So I should not shade B. So everything here I will shade apart from what? From B, like that. Then now I am being told that we have to find A union what? Union B complement. So I'm joining all these parts that I've shaded together. So you see that I just end up with only the middle part not being shaded. So I write that this is actually equal to, then I have that this is going to be the complement, and I have there A and B. Then just everything there I will shade apart from that middle part there. So this here verifies my A union B complement, like that. And just like that, we've illustrated the De Morgan's laws using the Venn diagram. All right. So next we are going to go to question 7. And question 7 is a proof question also, telling us to prove the distributive laws. And the distributive laws, so we have this first part and that part. So what we have to show is that A intersect B union C is a complement, or is contained, is contained or is a subset of A intersect B union A intersect C, like that. Then we also have to show that A intersect B, like that, is A intersect B union A intersect C is contained in A intersect B union C, like that. So showing this here, if these two hold, it means that A intersect B union C is equal to that other part on the right side. So how do I get to show this? So let's say I have an element. Let's say I have, so I say let X, I'll start with the first one, let X be a member of A intersect B union C. So this implies then that X is a member of what? Of the set A. Then the intersection here, I can just say and. So and X is what? X is a member of that second part, which is B union what? Union C. But this just implies that X is a member of what? Of A, and X is a member of B, or X is a member of what? Of C. So union there means the set, the element can either fall in the first set, it can either fall in B, or it can fall in C, or it can fall in what? In both of the sets. Whilst when you're looking at intersection, you're looking at the element being in both of what? Of those sets. But then what does this mean? So this just implies that if you see here, X is in what? X is a member of A, so I can say X is a member of A, I keep that. Or So, or I join the O part here. So, so you're saying X is a member of A and X is going to be what? A member of what? Of B, like that, since this is the statement which we have. Then we're saying O, it's like I'm distributing the first part with what is here. So X, a member of A, distributed to there, X, a member of B, distributed to there. So still here, X, a member of A. Remember, I'm doing nothing. I've not changed anything because X is still in A here. So X is in A and X is in B. Or X is in A, still haven't changed anything. And X is what? X is a member of what? Of C, which is that part which we see. But this here can just be written as X being a member of what? Of A intersect B, or X is a member of what? Of A intersect C. And this here just implies that X is a member of, so this implies that X is a member of A. So X is going to be a member of A intersect B like this. Then the O becomes our union symbol there. Then we're saying A intersect what? Intersect C. So it can either fall in the first part or it can fall in the other part, or in what? Or in both of them. That's what that union there what means. But then this is just the first thing. So this has just proved what? The first one which we wrote, to say if this is contained in that, so we've shown that X is actually contained in what? In the second part. Now let us show that it's, if we start from the other side or from the opposite side, that this second statement is going to be what? To be true. So how is that going to be? So I say that let X, now we'll say let X be in this here. So let X be a member of A intersect B, then union A intersect what? Intersect C. But what does this imply? This implies that X is a member of A intersect B, or X is a member of A intersect C. But this just means that X is going to be what? X is going to be contained in A, and X is just contained, or X is a member of what? Of B. Or I can say here on this other one, which is X a member of what? Of A, and X a member of C. So that, if that is true, then this implies that, so you see that both of them have X a member of A. So I can just factor out that to say X a member of A like that. Then what do I remain with when I say, so there's the AND part here, so I'm not leaving out that AND part here. So AND, so if I factor out that they all have this here, what do I remain with? I remain with X being, so I remain with X being a member of what? Of B, or X a member of what? X a member of C. So I just factored out this statement here and this statement, because they're true for both. Then this is what I remain with. So for a clear oasis, I could put brackets here. Yes, like that. But this just implies that X is going to be what? A member of what? Of A, and X is a member of O here means union. So X is just a member of what? B, union what? Union C. But this implies that X is in what? Is a member of A intersect what? Because of the and. So intersect, meaning X is in A, and of course X is also in what? In the union of B and what? And C, like that. So now if you look at what this is just what? The left-hand side. So this is the left-hand side which is there. So this now shows us that indeed that is a complement, is contained in the other one. Since both statements are true, it just means that indeed this we have proved this what? Distributive law. So hence what? So down there you could write hence shown. All right, so this is how you'd prove that. Now let's do the next one. All right, so on the next one, we have to prove. So question 8 says, prove that A is contained in B and B is contained in what? Is contained in C. Then if that is true, then A is contained in what? In C. Okay, so now here, let us just use pure logic and understanding to this. So they're telling us A is a subset of B. So what that means is every element that is in what? That is in A is in what? Is in B. So every element that is in A is in what? Is in B. That's what this statement means. The second statement then means that what? That B is what? Is a subset of C, means every element in B is what? Is contained in what? In C. So we have to want to prove that if that is true, then A is every element of A is going to be what? Contained in what? In C. Or A is a subset of what? Of C. So how do we prove that? So I can say let X be a member of what? Of A. So if X is a member of A, then by what we've been given here in the question, it means that it means that since A is a subset of what? Of B, it means, which is this here, this just implies that what? That X is a member of what? Of B. This implies that X is a member of what? Of B. So now, since that is true, and we are told that X is a member of what? Is a member of X, every element of B is contained in C, so it would mean that X, so every element of what? Of every element of B is contained in C. This just means that this here is going to be contained in what? In C, like that. So this then just implies that X is in what? Is a member of what? Of C. X is a member of C. But then you see where we're coming from. X is a member of A, and X is also a member of C. And X is just an arbitrary element. So if X is in A and X is in C, so if X is in A, so saying if X is in A and X is in C, then by definition, then this just implies that this implies that A is what? Contained in what? In C. And just like that, we have shown this part of the proof. All right, so the next one follows. So the next one is A union B. Then we are saying set difference of A intersect what? B, like that. Then this should be equal to A set difference there, union, then have B set difference, like that. Okay, so again, I just have to show that this first part is a subset of this part and the other part is a subset of the other one. Then these two sets are going to be equal. So let's say I have an element, again, X arbitrarily point, and it's in what? The first set, let's say it's contained in A union B. The set difference, of course, of A union B, then A intersect B. So if this is true, what does this mean? So this just implies that X is a member of the first one, A union B. It's contained in there, and X is not a member of what? Of A intersect B. So that is just by definition there. I've just used the definition of what that set difference is. But then if X is in what? Is in A, is contained in the union of A, union B, then the other one, we're saying X is not in what? Is not in A intersect B. But what does that then mean? So this means for the first part, X is going to be contained in what? In A, or X is what? Is contained or is a member of what? Of B. And for the second one, means that X is not a member of what? Of A, and X is not a member of what? Of B. So I've just expressed that. That's what that means. So now I want to get their right-hand side. So the right-hand side there, then you could see if we say A, there's the O here. If I then join it or combine with the AND part here, we were saying this here. So we say, not that there. We combine with the B part, with this B part there. So if we continue with this part here, so meaning we say X is going to be a member of what? Of A, and X not a member of what? Not a member of B. Just rewriting that. Or, so there's the O sign there. Or X is a member of what? Of B, and this part here that remain, and X is not a member of what? Not a member of A. So I've just rewritten it that way, and it did not change anything, just the same words, same letters, that same symbols that are used there. And then you see that X is going to be contained in what? So here, A just means that X is going to be contained in A, set difference of what and B. So because there it says X is in A and X is not in B. So meaning that that's a set difference of A and what and B like that. Or we're saying that X is what? X is a member of the set B. X is in B, but X is not in what? Is not in A. So I write it like that there. And what does this just give me? Let me erase this top part. So this then just we just end up having that X is actually X is a member of A, set difference of A and B. The O comes union, that's the union. Then we're saying B, A like that. So we've shown the first part that it's contained in there. So now how do we do the other one? So we follow it in the like manner, the way it is given. So it is given that way. So let us do that. Let us do that. Okay. So now we do the second part, meaning I start from the right hand side. I say let X be a member of A, not in B, union there, like that. This then just implies that X is a member of, so X is a member of A, B there, or X is a member of set difference of A and what and B. So this means that X is a member of what? Of A. For the first part, X is a member of A and X is not a member of what? Of B by definition. Or X here, in the second part, X is a member of B and X is not in what? X is not a member of A. So now, how can I rewrite that? So this here, you could see that if I say X is a member of A here, then we're saying the other part there to say X is what? X is, so X a member of A here, or we could get this other part here, X a member of what? Of B like that. So I just rewrite that to say X a member of A, or X a member of what? A member of B. So then, and on the other side you say then and you see that X, so X is not in A and X is not in B. So X is not in A and X is not in what? X is not in B. So X is not in what? In A and X is not in what? In B, like that. So this then just means that, so here X for the O, it means that it's going to be in the, it's going to be A, X contained in what? A union B, because it can either be in A or what? Or B. Then here we're saying and, so X a member of A and X not, X is not in A and X is not in B. So if X is not in A, is not in B, then it's not going to be in the what? In the intersection. So meaning X is not going to be contained in what? Or X is not a member of what? Of the intersection, yes. So X is not going to be a member of the intersection of A intersect what? B. But then by definition, this just means that this implies that X is a member of A union B, then they are set difference of what? Of A intersect B. So now we've shown that the second part, if you start from the right hand side, going to the left hand side, we're just going to show that the right hand set is actually contained in the left hand set. So we've shown the complement of, we've shown that the first set is contained in the second part, the second one containing the first part, and thus they are going to be equal. And thus we conclude that these two sets are equal just like that. Okay, what is our next question? So our next question, we move on to question 10. Again, we're still dealing with proofs here, still dealing with proofs. What do we do for this one? What do we do for this one? So, okay, so we're saying A union B, we have to prove that A union B complement is equal to A complement intersect B complement. So how do we do this? So again, if I show that A union B complement is actually contained in A complement in the intersection B complement, and the other way around, then these two sets are going to be what? To be equal. So again, I say let X be a member of, I'm using X because it's an arbitrary point. So X be a member of the first part, which is A union B complement. But this means what? So if X is in the complement of A union B, it means that X is not contained, or X is not a what? Is not a member of A union what? Union B. So X is not a member of what? Actually, if X is not contained in what? In A union B, if X is not contained in A union B, then it means that it is not contained in what? In either A or what? Or B. So you can get this from the Venn diagram. If you have a Venn diagram like this, and you have A, B, so A union B complement is actually this part here. So now if X is a member of A union B complement, meaning X is not a member of what? Of A, and you see that this part, the A and B are not shaded, meaning X as well is not a member of what? So X is not in A and X. X is not in A and what? And B. But this is just intersection. This is just intersection. So let me write it like this. So X is not a member of A intersect what? Intersect B, because if X is not in A and X is not in B, or maybe I could write that for argument's sake to say X is not going to be in A and X is not going to be what? To be in B. But this just implies that, so see that what we've said here to say that X is not in A and X is not in B. So if X is not in A and it's not in B, then it means that X has to be in what? In A complement, and here X has to be a member of what? Of B complement. But this just implies that X is a member of what? Of A complement and their intersection, because if it's in both sets, then it falls in the intersection. So in B complement. So proof started from X being a member of A union B complement. If it's in the complement, it means that it's it's not in A, it's not in A, it's not in what? In B. It's not contained in A, it's not contained in B. But then if that is true, then it's not going to be contained, it's going then to be contained in the complement of what? Of those sets. Then you get the results which you have there. Starting with the other one, conversely, we can say we start from, say, X, a member of A complement intersect B complement. What does this imply? So X a member of A intersect complement, that this just implies that X is a member of A complement, and what? X is a member of B complement. This then implies that X is not in what? X is not in A, then and what? And X is not in what? Is not in B, like that. So X is not in A and is not in B, but this implies that if X is not in A, it's not in B, then X is not going to be a member of A union what? Union B. So if X is not in A union B, what does this imply? This implies that X is a member of what? The complement of A union B. So X a member of A union B, like that, complement. So this shows us the second part, and just like that, we have shown that those two sets are equal, like that. Okay, so now we do the next one which follows. So the one that follows just tells us to show that A is equal to K. So it just tells us to show that A is equal to that there. So what is that which has been given? So I have that. So I'll use Venn diagrams here. So I'll say A intersect B here. So our A intersect B, like that. So there I have my A intersect B. So that is going to be the middle part there. That is my A intersect B. Then they're telling me union of what? Of these two with A intersect B what? Complement, B complement there. So like that. So then I get here, there. Okay. So then I get one there. So A, B, then, so it's saying that A intersect B complement. So B complement is everything outside B. So everything outside B, then where they intersect with the set what? With the set A. So let me shed everything outside B. So this is everything outside B. Apart from that set B, everything in the universal set, of course, but not in the set what? In the set B. then intersect what? Intersect A. So I shade my A and see where do those cross. So you see that they cross at this part of A. So writing this separately on its own, you see here universal set A, B. I just remain with this part there, that one there. So now looking at this, adding, or to say, since union, you're bringing everything together, you're actually kind of adding in this case. So even if I'd put a plus sign in between here, these two here. So joining these two sets together, you see that if I join them together, my A and my B, so A and B, that one has the middle part there, and that other one has the other part there, like that. But this is just equal to my what? My set A. So which is the other side there, and just like that, I have what? I have verified that this statement is actually true. Okay, so, okay, so let us do this. Let us do this. Let us do this. Let us do this. Okay, so now, what do we? So the next question is to determine whether the following statements are true and correct any if they are what? They are false. Any if they are what? They are false. Okay, so how do I do this? So the question says determine which of the following statements are true and correct any if they're false. So for the first one, they're telling us that x such that x is equal to x is equal to the set containing the empty set. The set containing the empty set. Well, this is false here. This is false because this x, the set of OX such that x takes up the values of x, it's not empty. So because it's taking up values, what values there. So others could have specified that there could be integers, there could be real numbers, but then we don't really care, but then it's taking up a value. So, and we're calling that value is x. And so it means that this left hand side is not empty, and thus it cannot be equal to the what? To the other side there. So how you could correct this is just saying, so x, correcting this other side, you could say in this case, you're having, it's a set of OX such that x is equal to what? To x. So that there you could write to say the set, then the values that this set is taking up are just any values of x like that. So like that there is what you could write. That x takes up what? Takes up x, like that. Okay, so that would be a correction that you'd make there. Then on the other one that is there, so you're saying that so A is equal to set of OX such that x squared is equal to what? To 4x greater than what? Than 9. And B is such that x is less than or equal to what? To 1. Then there they're saying then x is then A is contained in B. So this here written like this just means A is contained in B. So A is contained in what? In B. So now when you look at what's here, so what is A? So A is defined by this equation to say x squared equal to what? To 4 for x greater than 9. But then we see here that there is no value for x greater than 9 that to satisfy this equation here. So there's no value greater than 9. So just putting 9 itself here, we have 9 squared, which is 81, and 81 is not equal to what? So if I put 9 there, I'll have 81 equal to 4, and this is false because 81 is not equal to what? To 4. So meaning that the set A itself is going to be an empty set. So A is just equal to what? To an empty set. Then here we have the set B, like that. Okay, whatever B is defined by, we don't really care, but then A is the empty set. Here, they're saying that A will be contained in what? In B. Is A contained in B? So this statement is true. Is what? Is true, first of all. It's true, and the reason why is the empty set is a subset of what? Of every set. So since by definition that the empty set is a subset of every set, it's contained in every set, meaning that this empty set is actually what contained in what? In B. It's already there in what? In B. So meaning this statement here is actually true. By the way, this is defined because the empty set is a subset of what? Of every set. All right. So you have that there. Next, we're looking at the power sets. So power sets here, question 12 looks at the power set, and how do we define a power set? So the power set of A is going to be equal to 2 to the n, which is just the number of what? Of elements in that set. So for the first one, A, so you have A has what? So so this is just going to be 2 to the power what? To the power 4, and this is equal to 16. So it means that the set A in the first place has 16 subsets. So 16 subsets. And we need to write down those subsets. Wow. Determine the power set of, wow, we actually need to write down all of them. So there are a lot, 16, we need to write them. So we'll first start with the empty set, because I know by definition, the empty set is going to be a subset of every set. Then I write down, so the power set, just the number of subsets or the subsets that are there, possible subsets that are in that set. So the one that's then empty set, we said, is a subset of every set. Then the set containing A is going to be a subset because it's contained in what? In that set there. So I do individual elements. So A, like that. Then I do C. Then I go for D. So I'm done with this. Then now I do the pairs. So I can do set A and B. Then I go A and C. Then I go A and D. So like that. So with the ones that are crossing with A, I am done. So I then go to B. So B, subset, the set of B and comma here, set of B and C. Then I have the set of B and what? And D, like that. So done with this one. Then I go to C. So C, then C and what? And D. Since the other ones, if we cross them back, we just have repeating sets which we've already written already, like there. Then I do for 3. So the ones that have 3s have A, B, and C. If I put them there like that, then that can be a subset. Then the other one is going to be A, B, and what? And D. I leave out the C this time around. Then I leave out the B. So to say this is going to be the set of A, C, and what? And D. Like that, I have left out the what? I have left out the B in this case. I can still leave out the A also. So I have B, C, and what? And D, like that. So after having this B, C, and D, then of course, this means I have depleted all those three pairs that I'm going to have. Then the last set itself is just the whole set. Every subset is a subset of itself. So meaning the set what? The set A itself is going to be contained here. So this here is the power set of what? Of A in the first one. Well, I will not do B here because B is long. You can try it on your own because you know that you have 2 raised to the power 5, and that is just going to be equal to 32. So you have 32 subsets here, possible sets contained in this power set here. So yeah, so you can try that on your own. But we do the C. So C here, if you see the elements we have 1, 2, and 3. So these sets there, since we have a set A and it's a set of sets, since A is a set of sets, we consider those sets in A to be just elements of what? Of A. So meaning the power set of that A in the part C is just 2 raised to the power 3, and that is going to be what? To be 8. So you have 8 subsets that are contained. So power set of A is going to be equal to my 8 what? Subsets. So I have to write them. First of all, empty set is there. I should not forget that one. Then the next one is the set containing the set A and what? B, like that. So that set there. Then the next one, so I do them individually. C containing C there, like that. Then the other one, the set containing the set D E, F, like that, and that there. Okay, so I have already written down 4, so meaning 4 more to go. So 4 more to go. So now I can combine. Let me combine where I say, okay, I'll say A and C. So the set that is going to contain the set, I mean the first part, which is A, B, the set of A and B, and contain the set of C, like that. Okay, so 1, 2, 3, 4, 5. Okay, 3 more to go. So I can combine again the set AB, the set that contains the set AB, and the set that contains the set DEF. Combine them. So I have the set containing B, like that, and A, comma, the set D, E, and what, and F, like that. So this one here is my number, this is my number 6. Then I do now the 7th one. I'll do this C and that part. So the set containing the set C, comma, there D, E, F, like that, then like that. Okay, so 1, 2, 3, 4, 5, 6, 7. Oh, one more to go. But which one is that? All right, you're right here. So we have to just get the set itself, since the set itself is going to be a subset of itself. So the set A itself is going to be the what subset. So you can just write it there again like that. So this then handles that part of question C. Right, the next one. So next one, we go into product, the Cartesian product, where we are saying that we need to find this here. This is our A, B, and C. Then they're telling us find A cross B cross C. So you have to cross every element of A. So if I start from 1, here in A I have 1, I have to cross it with every element here. So I have to cross it with the element in B, cross it with an element in C, but then it's every element. So I go again 1, then I cross it with, I'll go X, then cross it with 4, such that I handle the C's, then the C's are out. Then I go again to the next one, where here I'll say it will be Y. So it will be 1, Y, then I go 3, then Y, I go again 1, then again I go Z, 1, like that, like that. When I finish, I move on to 2, and just like that, we continue to list that one. So now, what is this going to go to? So I said we start from 1. So this here is going to be the ordered pair, 1, comma. I cross it with what? X first. So X there. Then in the last set, we have what? We have 3, like that. Okay. So still keeping the point, standing on 1, 1, and X. So standing on 1 and X. Then I just change the last part, which is what? Instead of going 3, again, I go 4. So I go 4 there, like that. I cross it like that. Then still 1 now. What is going to change is the middle what? The middle element. So Y here. Then Y, I cross in C with what? With 3. Then I go again 1, comma Y. Then I cross with what? With 4, like that. Okay. Still. So now I was changing the middle part again, Z. I have to use all those. Then I get 1. Then I go here to be Z. Then I get a 3 there. Then the other one is 1, Z, and 4 there, like that. So this is what I get, 1, Z, and 4. So now I have done 1 with everything, meaning I move on to what? To 2 in the set A. So 2, then I go again. So 2 go first X, then 3 in what? In C. Then I go again 2, X, and what? And 4, like that. So what's just changing now? Where there's 1, there's just going to be what? To be 2 there. So like that. Then I go, next there is 2, Y, and 3. Then I go 2, Y, and 4. Then I go that to be 2, Z, and 3. Then I have 2, Z, and 4, like that. So this here is going to be that Cartesian product which I am looking for. All right, so that's how you solve this question. moving on to question 14. Question 14 says, find the value of x that is equal to that. So I have ordered pairs x comma y and x plus y, and this equal to x comma, 6 comma 2. So these are given in pairs, that pairs x comma y, x comma what, comma y, like that. So it means I equate the x part to the x part, the y part to the y part, and so for that. So in the first part, I'll be solving for x. Since I equate 2x to 6, and I just get that x here, divide both sides by 2, I get 3. So x is equal to 3. Then the other part, x plus y, I equate it to 2. Oh, I have already found an x value, which is 3, plus y is equal to 2. Take the 3 the other side, I just remain with y. Then that will subtract, then I have negative what? Negative 1 there. So then, therefore, my solution is x is equal to 3 and y is equal to negative 1. So I've solved that. I do the same for the other one. So find the value of what? Of x that. Okay, so I think we found the value of x and y. Then when we could replace here, you could see if you replace, we found x to be 3 there. Then the other part, x was 3. Then we found y to be negative 1. And this here, if we place back, we just get 6 comma 2. Okay, so let's do the same for the other one, which is y minus 2, like that, 2x plus 1 there. Then I have x minus 1, then I have y plus what plus 2. So they're telling us to find this here. So how are we going to get this? So I have this part and that part, I equate them. So y minus 2 equal to x minus 1. Then I can make y the subject here. So making y the subject, the negative 2 goes that side, becomes positive, and I just remain with this will be a plus 1. Then I do the same for this and that. So I have 2x plus 1. Then this here is going to be equal to y plus 2. So this is what I get here. I can still make x the subject, y the subject. So if y is the subject here, so y, the negative 2 goes the other side here, I have 2x. The 2, goes the side, becomes negative 2, then I remain with 1, like that. So I have x and 1, like that. Then I can just equate these two equations. They have y there, there's y there. Then I can equate them. So x plus 1 is equal to 2x minus 1. And then taking that x there and that going there, I just have x is going to be equal to 2. So x is going to be equal to, since I subtract here, when this x goes that side, becomes negative x. So this becomes x, and the negative goes the other side, becomes positive, and this becomes 2. So x is equal to 2. Then I replace there in any of them to get my value of y. So where there's x, okay, where in here, where there is x, I replace there, or in that other part, whichever. So you just see here, I have, okay, so here I'm going to have, you replace in here because you had replaced this equal to that. Okay, or whichever, because in here you have different values. So meaning this part here, when I replace with, so when I replace that there, what do I get? So I say y, okay, y, x plus 1. So why there's x, I have 2 plus 1, this gives me 3. Then on the other one, here I just have 2 by 2 gives me 4 minus 1. This also gives me what? 3. So I just get the same answer either ways. So my y value, so x is equal to 2 and y is equal to what? To 3, like that. All right, so that's what I get. Okay, so let's do, so this is gonna be the last proof, I hope, in this tutorial sheet. So they're telling us to show that a cross product with that is equal to that, and just like that. So now what you ought to understand is that the cross product of A and B, let's say A and B, or let me use different ones. Let me say X and Y, cross product of A, X cross Y this is just defined as x comma y such that x is a member of x and comma y a member of what? Of y. So by definition, that's how you define that. So now we'll do the same and show that, oh, this is containing the other part and that part is containing the other part. So then they're going to be what? To be equal, having this in mind or having written this down. So I have that. So I say I say a comma b. So let a comma b be a member of what? Of A cross B intersect C. This then implies, by definition, this means that X is a member of A, comma, then B is a what? Is a member of B intersect C, like that. So a member of A, comma. So B intersect C, I can write this, so I can just this means that X is in A and X is in what? Is in B, like that. So meaning here, I mean B is a member of B, and that means that X is a member of what? Of C, like that. So if I say I am distributing the comma part there, so this implies that X is a member of what? Of A, comma, B a member of what? Of A. Then I say, and if I'm still getting the X here, so the A, I mean A member of A, comma, X a member of what? Of C. Didn't change anything, still the same here. But this then implies that, so this implies, by definition, this is just A cross B, and the and is the intersection. Of course, then I have that is just A intersect what? Intersect C. So this shows the first part. So this shows that this here, which implies that this here is a subset of what? Of A cross what? Okay, no, but the other way around. So this implies that the A cross B intersect C is contained in A cross B, then intersect A intersect what? Intersect C, like that. So this here is what that shows, or what that means there. Okay, next, I do the opposite, meaning I start from the right hand side, then I try to get what I have in the left hand side there. So there I'm just going to have that A cross B, like that, intersect A cross C. I say again, if I say let A comma B, let A comma B be a member of this here. Let A comma B be a member of that. So this then implies that my A comma B is a member of the first part, which is A cross B, and it's a what? Since there's intersection there, and A comma B is a member of the second part, A cross what? Cross C there. So this is what this means. But what does this imply? By definition, the first part here, this member of that, means that A is contained in A, comma, the B is a member of what? Of B. And then this here, the second part, is just A is contained in A, comma, the B is a member of what? Of C. So like this now. But then this implies that if I say I factor out my A, comma, my A, a member of B here, since they all have that, I put my comma there. What I just remain with is I remain with B, a member of what? Of B, and B a member of what? Of C. But this just implies that A is a member of A, comma, so the B in the member of C in B and in C means that B is just a member of B intersect what? Intersect C. And this implies that by definition, this just is that A comma B is a member of what? Is a member of, so this just means no. I write this nicely. So this here, by definition, is just going to be that A is in A, so meaning A there, a comma means the cross, then B in the other part would mean A intersect what? C, like that. So this is what this means by definition. But this here is the subset now. So meaning we've shown that the second part is a subset of this one. And since they're subset of each other, then they are what? They are equal, hence the proof. All right, question 17. Question 17 tells us to write the interval in what? In set bit notation. Write this interval in set bit notation. So it's an open interval, meaning 6 and 12 are not part of that interval here. So meaning I have this, I'll say the set of OX such that, so X is defined between two numbers here. So X is in between 6 and X is in between what? In between 12, like that. So X is a member of X such that X is in between what? In between 12. And since it's been given as an interval there, meaning it can get numbers, any numbers between there. So I presume that X is a member of what? Of the real numbers, like that. So, and like that, this you have what you have proved. Okay. So next says show the following on a real line. So real number line is what we must show. So A, we draw our number line like this, and then our number line we say from negative infinity to infinity. Then they're telling me to show or to plot 2. So here it is less than or equal to on the first part, less than or equal to on both sides, meaning those parts are part of what? A part of that interval I'm looking for, or part of my set. So I have, if you like, you could draw, or you could write values to say 0, -1, and all the way, of course, but I will not write all of them there. Then I say 2. Okay, I'll write 2 and say, let's say 8 has somewhere there. You could write this. So then this means that 2 is in both sets. So 2 is contained because of that less than or equal to. Then 8 also, it goes all the way up to 8, and 8 is contained because there's that equal to there. So this here is how it looks on my number line. I go for the other one, negative here, positive infinity. So this is X greater than 7. So if I have my 7 here, it means that, and it is greater than, strictly greater than, meaning I'll have an open circle on my 7, then it's going all the way up toward positive infinity because it's showing us the right direction there. So that's what I get. Then I go now, let's write the next one. So the next one here is just X being between. So I go negative here, then I go positive there. So this here is just negative. So I have -2 here. Okay, I'll just write my 6 there. So at -2, it's open because there's a less than, strictly less than, but on 6, it's less than equal to, so it's going to be what? Closed there at 6. So just like that there, that's how I write it on my number line. The last one here on this question is, so we have negative infinity to infinity there. So the first one, 4, let me say my 4 is here, saying 4 going to what? Going to negative what? Negative infinity. So it's open at 4. Of course, it's always going to be open at negative infinity because you don't know what, that's not a fixed point which you know. Then it's saying this is my 4, and if I say my -2, let's say my -2 is somewhere here. For the second part, -2, then I have my 5 here. So that tells me it's closed on both sides because of square brackets. So it's closed at 2, and it's closed at what? It's closed at 5. Then they're telling me to find the intersection of these sets here. So where do these sets intersect here? So they intersect here and there. So they intersect here and there, but not at 4, because what? 4 is not contained in what? Is not contained in that interval. So 4 is not in the set, in this first part, is not in that set. Because it's not in that set, meaning it cannot be in the intersection. That point 4 itself cannot be what? Cannot intersect in that set. So if I'm to write this, meaning I'm going to have that, I'll go from negative infinity to positive infinity. Then I'm going to have that this is going to be 4. Then I'm going to have what? -2 there. So at -2, it is closed, but then at 4, it is what? It is open. So I'm going to have what here, which is open like that. And this here is my what? My set like that, shown on a what? On a Venn diagram. I mean a number line. So the last part now of our question, finally we get there, and this is question what? 19. And this question 19 says, write the following using what? Interval notation. So they're given in set beta notation, we have to write using what? Interval notation. So how do we write this in interval notation? So now you just look at, oh, my x here, it's a set of OX such that x is a real number that is contained between -2 and 7. And since it's less than or equal to on both sides, it means that those values, these values here, -2 and 7, are actually contained in what? In my set. So I'll have it -2, comma what? 7, like that. Then B, so for B, it's x greater than 9. So meaning it will start from 9, increasing, going to what? To positive infinity. So 9, it's strictly greater than, meaning 9 is not part of that interval. So I'll have 9 all the way to what? Positive infinity. So that's for my B. And my C is, so for my C, is 0, between 0 and 5, but then looking at the 0 part here, 0 is not contained because it's strictly less than. So mean to write that, it will have an open bracket there at what? At 0, comma, I'm going to what? To 5, and 5, at 5, it's less than or equal to, so that means it's going to be closed there to have a square bracket. Okay, so the last two questions. So we have then that this we're going to have that x. So x, so the first part here of D, so you see how D is written. D is x such that x is less than what? Less than 8. Intersect x such that x is greater than negative what? Negative 4, like that. So this here then, for the first part, means that x is reducing. So from 8 going down, 8 to what? To negative infinity, and it's strictly less than, so meaning 8 is not part of that interval. So meaning I'll have this here, the negative what? Infinity there, like that. So intersection, of course, negative infinity, you can't intersect, you don't know, that's not a fixed point there. Then the other one is from negative what? Negative 4, negative 4, then it's going all the way to what? To positive infinity. Then they're telling you the intersection of these parts here. Where do these two sets intersect? To simplify, because you have to write this in that notation. So let me write it first on a Venn diagram. So you have negative infinity, I mean on a number line, negative infinity to positive infinity. Then negative 4 here, then you have your 8 there. So the first part is from here, it's open, going this side. The other one, it's here, it's open, and it is what? It is going the other side. So these here intersect here, like that, here in between. But then if you see from here that they are open on both sides, meaning negative 4 is not in that set, negative 8 is not in that set, meaning they cannot, those 2 points cannot intersect. But this then just means it will simplify to negative 4, comma what? Comma 8, like that. So this here is my set D, written in what? In interval notation. Then E, let us look at E. Let us look at E. So E is a set of OX such that X is less than -1, union set of OX such that X is greater than 2. So how do we work this out? So it's -1. So from -1 reducing there, and -1 strictly less than, it's not part of that interval. So -1 and strictly reducing. So that's negative infinity. I close, union. Then there it's from 2 to, then it's what? It's increasing to what? To positive infinity. So they're saying just bring everything here together. So you can see this even on a number line. If I say negative infinity, infinity there, then this is just going to be, say I have my -1 there and my 2 there. So 1 is going here, it's open here, going that way. The other one is going here, open, going that way. So now, like this here. So if I look at this here, the union of this is just everything here, like everything that is there, and it will not change anything. It means my set is just going to be my set there in E is just the same set. Okay, and this marks the end of what our tutorial sheet 1. Right, if you are new to this channel, remember to hit the subscribe button, and we will see you in the next one.